So, good evening, friends. Today we are continuing the pending session of the last session. So, in this session, we will only discuss on the experimental research design. The one thing which I can say on this topic is this topic is having a lot of publication potential. So, uh, although the experimental design are very famous and very popular in medical health, psychology, these areas, pharmaceutical. But in management also, researchers are conducting experiments. But most of the time, the focus is on questionnaire data. But if they learn how to conduct experimental research design, the publication potential will increase. So with this point, we will going to start. There are basically three type of experimental design: the pre-experimental, true experimental, and quasi-experimental. The statistical normally is not included in this. So we have three types: pre, true, and quasi. So both, all the three research design, we are going to explain in this session. Now, so experiments are very famous in research. So we have different experiments. So to start this session, I'm taking one example of. So there was an experiment called Hawthorne experiments. So these experiments was 100 years back. So around 100 years back, the companies are going to start the manufacturing. So manufacturing start was started all over the world, especially in US. So in these companies, they hired labor class. So it was a new era. So when company start manufacturing different products. So during that time, the focus was on increasing the productivity. How can they produce maximum and maximum? So to all the experiments which were conducted during that time was to increase the productivity. So one set of experiments known as Hawthorne experiment, they found that if you provide lighting, hygiene, cleanliness, and good temperature, the productivity increases. So they divide the labor into two categories. So one category is normal category, normal condition, whatever condition they are working. So same conditions. And in other condition, other set of labor, they provide good food, hygiene, cleanliness, good light, temperature, and they found that the production was high. So experiments are very old, and now these experiments are very common in some areas. So in experiment, what we are going to do? What is the objective of these experiments? The objective of these experiments are to establish the cause and effect relationship. Like in case of drug, the drug is the cause, improvement is the effect. So similarly, now people are comparing offline education, online education. So these are the cause and learning is the outcome. So we want to establish the cause and effect relationship between the two variables, independent variable and dependent variable. So evidence of causality. So basically the logic is that the order of events, causal order of events. If one event happen, it will lead to another event one by one. Then two phenomena vary together, or by an absence of alternative explanation. So by conducting these experiments, you are measuring different variables simultaneously or at a different point of time to show that they are related to each other. So it's very common in psychology, health science, medical, and pharma, as I told earlier also. Now, in all the experiments, so there are two type of groups. So one is control group, where we are not doing any experiment as it is, and other group where we are doing experiment is called experiment group. So there are two groups always. In some cases, we have only experiment group, and we are providing different treatment to different groups. So treatment one, treatment two, treatment three. So we are having three experimental groups, and sometimes we don't have any control group. So whether to keep control group or not control group, it depends upon the area to area or experiment to experiment. Like in pharmaceutical, there may not be any control group because you are trying different drugs and find out the best of the drug, best of the combination, like that. As I already explained, these symbols: O means measurement, X means experiment, experimental group, control group, randomness, and the measurement. Balancing of the different groups. All the groups must have same number of units. Now, the designing of the experiment is the most important part of the experimental design. Because whenever you are conducting a experiment, there are so many control environment, control variables. So you have to take care of these control variables. There are many disturbance variables. Disturbance variables are those variables which can impact on the outcome. So you are thinking that the outcome is as a result of experiment. जो भी outcome आ रहा है वो क्यों आ रहा है? Because of experiment, but outcome is affected by some other reasons also. So these variables are known as extraneous or disturbing variables. So we have to define the experiment clearly. Okay. Now, there are some basic issues in experiments. Manipulation of the independent variable, dependent variable measurement, selection of the test unit, allocation of the test unit to experiment group, control group, and to minimize the effect of disturbing variables. So these are the four issues we have to take care of. So all the treatment, normally in the experiment designs, the treatment is independent variable and outcome is dependent variable. So you have to define that how we can measure the independent variable. Like one example I'm giving here. One of the PhD scholars decided to find out the impact of meditation on the, let's say, happiness. Now the question is that how can we introduce the meditation of the participant? So the scholar decided to divide the respondent into two groups. So in the first group, he asked for the mobile phones and download a app for meditation. And anybody who spent 5 minutes, 10 minutes on the mobile app is recorded. So by this method, we can identify that how much time the person is spending with the mobile app. And the mobile app is designed in such a way that it is a instruction based meditation. and other group is not providing this mobile app. So here the independent variable is meditation, and it is available for one group, other group is not. And here the problem is that the group which is control group, by chance somebody is already doing meditation. So we have to find out, cross check that anybody who is doing meditation should be removed from that group. So there are many things which we have to take care of. So finally, we select both group in such a way that in control group, nobody is doing meditation at all. And in the second group, experimental group, nobody is not doing meditation now, but they have to do in the period of experiment. So initially, we measure the level of happiness of both the group, and it is expected to be same because if we are in the beginning. At the end of the 3 months, on the basis of the experiment, we again measure the happiness and want to prove that those people who participated in the meditation program now are more happy. So designing of the experiment requires a lot of discussion. So finding out the chances of problem, so where problem may come. So designing is very important. And dependent variable is that how what you are going to measure. So in this experiment, we are going to measure the happiness. There is a scale already defined for happiness. So we are going to measure the happiness of the both the groups. And by applying t-test and ANOVA test, we can prove that this group is having more happiness and as compared to other group. So dependent variable and independent variable are predefined, and how they can be measured is also defined in advance. So dependent variable is expected to be influenced by treatment. So this is one of the assumption we are keeping in the dependent in the experiment, that whatever be your dependent variable must be influenced only by independent variable. Okay. Then test unit is a concept that who are going to participate in the experiment. So there are two things which we have to keep in mind. Number one is randomization. Every group must have randomly selected units. Units must be tested randomly so that initially experimental group and control group should be same. Number two, balancing. Balancing matlab the number of test units in both the groups should be similar, not equal, maybe similar, 40, 50, 45, 55, like that. So they must be similar. And there is a concept of blinding. Blinding means whether the test units are aware about the experiment or not. So in case if they are not aware about the experiment, it is called single blind. Double blind means those who are conducting experiment and test units are not aware, double blind. And even organization who is taking responsibility of conducting the experiment is not aware. This is happening in case of drug because the drug composition is not clear to everybody. So in that case, it could be double blind, triple blind. Now, the chances of error in experiments are very high because you cannot control each and everything. You cannot control human behavior. You cannot control environment. Sometimes temperature fluctuates, sometimes voltage fluctuates, sometimes the behavior of the participant fluctuates. Like, for example, you say that you have to be away from these things. Like whenever you are giving medicine, you have to instruct the patient that they cannot consume liquor or some intoxicant toxic things, but they are doing it while taking the medicine. So in that case, you are not having complete control over the patients. So these problems bring error in the experiments. So you have to take care of all the problems, errors which can be can come during the experiments. Constant error means the error which is not taken care of from the beginning. So this error will be throughout the experiment and will disturb your outcome. Random errors means which is not predicted earlier but happens in between, like death of a patient, like the uh, fluctuation in the voltage, fluctuation in the environment, or fluctuation in the human behavior. So maybe a random error. Okay. Now, the first of all, we have to identify that what could be the problems in the experiment. So these variables are known as extraneous variables. So what is extraneous variable? Extraneous. This word is very important in extraneous in experiment. Extraneous variables are those variables which can disturb the experiments and because of which your outcome may suffer. Like for example, in education, you are decided to teach three classes, one by Blackboard, one by case study, one by PPT. So you have three kind of treatment, and you want to see that which group is performing better, where the learning is better. So in this process, there could be many problems. Like for example, the student can discuss with each other the because you are assuming that all groups are independent to each other, but in the evening they are talking to each other what they learn. So these sometimes these problems will disturb your results. So these extraneous variables you have to control, identify and control. Like in this case, what is possible that you can select three classes in three different schools, three different colleges, so that they cannot meet with each other. They are not aware about the experiment. So designing of the experiment should be in such a way that disturbance should not come. Now we have to uh, increase the possibility of internal validity. What is internal validity? आपका जो outcome है, the outcome of the experiment, how much depends upon the experiment? How much outcome depends upon the experiment? This is called internal validity. Like suppose you are giving the medicine to the patient, how much their improvement depends upon the medicine is known as internal validity. Now, internal validity is disturbed by the extraneous variables. How it is possible? Like, for example, you are giving a medicine to the patient and give some precautions that you should not do these things during the experiment, during the medication. So normally डॉक्टर कहता है कि भाई आपको ये नहीं करना, ये नहीं करना, ये नहीं करना है. So you आपको परहेज करना है इन सब चीजों का. But if the patient is not doing the precautions, then outcome may suffer definitely. So internal validity, you need to prove that whatever result I'm getting is because of my experiment and I control all the disturbing variables. So now what are the disturbing variables? I'm going to explain. So we divide the disturbing variables into 6 types. Number one, history. History. History means while conducting the experiment, some sudden error comes. Like लाइट ही चली गई, आप लैब में एक्सपेरिमेंट कर रहे हो, लाइट चली गई. So specific events in the environment between the before and after experiment that are beyond the experimental control. So sometimes what happens, if you are conducting experiment on the human beings, they can change their behavior. You are doing on machines, machine में क्या होता है, कई बार हैंग हो जाती है, लैपटॉप हैंग हो जाता है. So these kind of problems, which is beyond your control, is history. So whenever we are conducting the experiment, we can identify the possible error which may come during the experiment. So you have to note down all these things and take care that these problems must not come during the experiment. So then the second is maturation. Maturation means sometimes what happens, the patient came to know that experiment is going on me. उनको पता लग जाता है कि मेरे ऊपर एक्सपेरिमेंट हो रहा है, तो दे वो मैच्योर हो जाते हैं. सो दे बिकम मैच्योर एंड sometimes the subject become tired. Sometimes the machine which you are using is also have some wire and tear, क्या कहते हैं उसको, मशीन भी यूज घिस जाती है थोड़ी सी. So wear and tear in the machine. So these kind of problem may come. Maturation, the human being mature, machine, because of wear and tear, the measurement may change. So this problem may create problem in the experiment. Testing. Testing means sometimes whenever you are measuring the some variables, the patient become very cautious. Like suppose whenever you take a photograph of some person, they show some extraordinary behavior. जब आप किसी की फोटो खींचते हो या वीडियो बनाते हो, तो उनका बिहेवियर चेंज हो जाता है. So they are sensitized, right? So the people, when they come to know that the experiment is going on us, so they sensitize and change their behavior. So the moment they came to know that the activities are recorded, so your behavior is sensitized and change. Then instrument. Sometimes you need to change the instrument because of the problem. So change of the instrument may have an impact on the outcome variable. Sometimes what happens that the instrument which you are using for collecting the data or measuring the data is not measured properly. So you change it, and because of this change, some changes will come permanently. Then selection. Suppose you are not doing random selection of the experimental group and the control group. So because in most of the cases, the experimenter is doing convenience sampling. किसी को भी किसी group में डाल, ऐसा नहीं होता. So if you are not doing the random selection of the units, then the problem will definitely come. Mortality means sometimes what happens, some of the people leave the experiment in between because of death, because of willing, unwilling, whatever be, but they withdraw from the experiment. So in that case, you have to include other participant for measurement. So this is called mortality. So there are many, these are some of the problems which may come. So actually, whenever you are doing the experiments, you need to design all the problems which can come while conducting the experiment. So controlling all these things is known as the controlling extraneous variables. Anybody who is conducting the experiments has to make a list of these possible disturbance variables and the method they adopted to control them. जब आप कोई एक्सपेरिमेंट करते हैं तो आपको वो एक लिस्ट बनानी पड़ेगी कि क्या क्या प्रॉब्लम आ सकती हैं और हम उनको कैसे कंट्रोल करेंगे. So this portion is very important to prove the internal validity of the experiment. Now, after that, we are having many designs, research designs. And these research designs are developed in such a way that most of the problems will go. So by designing the control group, comparing with the control group, random assignment, and measuring the variable outcome variable before and after. जैसे मान लीजिए आप स्टूडेंट या आप पेशेंट को अलग अलग ग्रुप बना रहे हो, आपने पहले सभी की बीमारी चेक कर ली कि ऑल आर इक्वल प्रॉब्लम, ऑल द पेशेंट्स आर हैविंग equal problem, so you are confirmed that both the groups are same. So this is called pre-testing. Pre-testing to confirm whether control group and experimental group are same or not initially. After the experiment they must be different, but initially they should be same. So pre-testing means to confirm whether the both the groups are equal initially or not, and post-testing means now what is the difference. And only post test only, sometimes you don't check initially or check only out after. So these are the different options we are having to confirm that experiments are best. Now I'm going to teach you the three kind of experimental design. So as I mentioned in the first slide, so these are pre-experimental, true experimental, and quasi-experimental. In pre-experimental, we have three groups, three test experiments, one shot study, one shot, one group pretest post-test, static group. So like this, and Solomon 4 group, only control group. So these are the possible experiments in pre-experiment, true experiment, and quasi-experiment. But on my conclusion, on the basis of my experience, I can say the pre-experimental and true experimental are not very popular. They are having a lot of problems. Now you have to use the quasi-experimental designs. So in quasi-experimental design, we are having four types. Then randomized block design, Latin square design, and factorial design. Randomized block को हम दो कैटेगरी में डिवाइड करते हैं, रेंडमाइज्ड ब्लॉक डिजाइंस. एक सिर्फ रेंडमाइज्ड, दूसरा रेंडमाइज्ड ब्लॉक, तीसरा लेटिन स्क्वायर, एंड फोर्थ इज फैक्टोरियल. And some are using Solomon 4 group. So what are these experiments? Let's say. So the first is one shot design. So one shot design means if you see the symbol, X is for experiment and O is for measurement. You simply give the treatment and then measure the outcome. That's it. There is no control group, there is no experimental group. You just conduct the experiment and measure the outcome. Bas. So you know that this is not a very popular design. So for your information, that is OXO1. X means experiment, O1 is measurement. One group pre-test, post-test. First of all, you measure the variable, give treatment, and then find out the outcome. जैसे मान लीजिए आपने बुखार चेक किया, दवाई दी, फिर बुखार चेक किया, like that. So for example, you measure you conduct a quiz, measure the knowledge of the students, then you do the experiment, and then again take the quiz to find out is there any improvement in the learning happens or not. In marketing, you measure the sales, daily sales, average daily sales, offer the or announces the some discount or some offer, some sale promotion like that. And after that, you find out is there any increase in the sales or not. So this is called one group. There is only one group, pre-test, post-test. But frankly speaking, not popular in PhD. So third is static group design. In a static group design, There are two groups. One is experiment group, one is control group. Control group, there is no experiment. You can see there is no X. In control group, only there is a measurement. In experimental group, you do some experiment and measure the outcome. And in this case, the O1 outcome of the experimental group must be better than O2. Why? Because they are suffering some experiment. पर जिसको दवाई दी है उसी में इंप्रूवमेंट आएगा, जिसको नहीं दी उसमें इंप्रूवमेंट नहीं आना चाहिए. Like I'm giving you one more example. During the COVID time, the most of the hospitals are conducting experiments on the different medicines. And one of the experiment, the data was come to me. The doctors are conducting the experiments on COVID patient. They divided the COVID patient into two groups. To one group, they are providing the plasma therapy, and the second group, they are providing the routine tablets. Because at the time there was no prescribed tablets, prescribed medicine. So after conducting this experiment, in this case, the experiment is plasma therapy. So giving plasma therapy to the COVID patient is the experiment. And not giving plasma therapy is control group. So here the name of the experiment is plasma therapy. And now they are, after giving the therapy, they are measuring that in how many days the patient recover. Whether the recovery of the patient is fast in plasma therapy or in normal treatment. So this, in this case, the experimental group is the group where plasma therapy is given. Control group, plasma therapy is not given. And they are comparing that which group is which group, plasma group or control group, is taking less time to recover. So almost every hospital, big hospital, was involved in this kind of study. Now, the second is true experiments. In these true experiments, we are having pre-test, post-test control group design. So these are the better design as compared to previous one. So we are having both experimental group and control group. So in first group, R stand for random assignments, means we are assigning unit randomly to the experiment and randomly to the control group. So, and this R, after random assignment, we are confirming whether these groups are similar in terms of outcome or not. Outcome, if your outcome is learning, so initially they must have the same learning, same knowledge. Like if you give the medicine to the patients, so all the patient must be equal before the experiment. So one group is giving experiment, second group no experiment, and we want to prove that O2, the measurement of experimental group, must be better than O4. यहाँ पे O1 की वैल्यू O3 की वैल्यू बराबर होनी चाहिए because initially they must be same, but after experiment O2 must be better than O4. Similarly, we are having post test only. if इसमें आप O1 O2 को हटा दो, O1 O3, this is called only post test, but this is not very good because in all kind of experimental tests, this O1 O3 should be equal and should be measured. It is almost compulsory to measure O1 and O3 to confirm whether initially both the groups should be same or not. Now, the best experiment design in this category is Solomon 4 group design. In Solomon 4 group design, you have two control and two experiment. So every group is assigned randomly, and in any one pair, we measure the O1 and O3. We are not measuring in other group. So experimental group is providing experiment 2, experiment 1, दोनों को हमने experiment किया. Both the groups are providing the experiment, providing the treatment. And after providing the treatment, what we want to prove that O2, number one, O1 is equal to O3. To prove that initially they are same. Then O2 equal to O5. O2 इक्वल टू O5 का मतलब है कि जिस ग्रुप को एक्सपेरिमेंट किया उसमें सिमिलर इंप्रूवमेंट आया. O2 इज इक्वल टू O5, है ना. जहां पे भी आप एक्सपेरिमेंट कर रहे हो दोनों में इंप्रूवमेंट होना चाहिए. बोथ ग्रुप मस्ट हैव सिमिलर इंप्रूवमेंट. O4 O6, O4 O6 जिसमें आपने एक्सपेरिमेंट नहीं किया, both the group must be same outcome, must have the same outcome, and O2 must be better than O4 and O5 must be better than O6. So you have, after proving all these relationships, you can conclude that the treatment leads to better improvement. So Solomon group design is better in all the three cases. Okay, so now we are moving to the advance. And these advanced are known as quasi-experimental design, advanced experimental design. So they are more complicated. And we are having four types of uh, experimental designs. So एक एक करके धीरे से समझते हैं. And I hope after this session you will have complete clarity. Now the first is completely randomized design. So completely randomized design. So suppose I'm giving you one example. So you are having a piece of agricultural land and you want to test which fertilizer is the best. So let me. So you are having the agricultural land and you are having X, Y, and Z fertilizer. So there are three fertilizers you want to check which is the best. So what you are doing, you are dividing the agricultural land into different blocks, into different, you can say, groups, and you randomly assigning X, Y, Z among all. So you just assigning randomly. ये मैं तो लिख रहा हूँ, but you are assigning randomly. So it means in this block area, you are providing X fertilizer, Y fertilizer, Z fertilizer. And after some time, you are measuring the outcome production. So you have to calculate the average production of X, then average production of Y, and average production of Z. And after that, you can apply one-way ANOVA test. The name of the test is one-way ANOVA to check which fertilizer is the best for the farm and which fertilizer is the least or least production. So in this case, the random assignment of the treatment in the different groups is known as completely randomized design. So this is one of the example of completely randomized design. Now in next, now this is the advanced version of completely randomized design. This is called randomized block design. उसी एग्जाम्पल को अगर हम देखें पुराने वाले एग्जाम्पल को, suppose this is the agricultural land. We divide the agricultural land into different blocks, and within block we assign randomly X, Y, Z, X. So within the block Y, Z, X, Y, X. So what we are doing, we are dividing the units into different blocks, and each block is divided into different groups. Another example I'm giving you, because this example is not fitting here. So I hope next example will make the things more clear. Now, suppose you are having the patients. First of all, you divide the patient into homogeneous groups. Let's say the first group is men, the second group is of women. So you can make two groups. Another possible groups are the young patients, the middle-aged patients, or old-age patients. So this is group number one, this is group number two, and this is group number three. Or you can do one thing, the patient on the basis of marital status, the unmarried, married, or single. So the first step is to divide the patients in some homogeneous group. Now within the group, suppose you are having two drugs, X and Y. So young people are divided into two groups. One group is providing drug X and second group is providing drug Y. Similarly, middle X and Y, then X and Y. And this is allocation is doing randomly. So here there are two levels. In this case, there are two levels in which the randomized block design. I am talking about randomized block design. So units are divided into homogeneous groups. Homogeneous group like male, female, married, unmarried, like that. According to some known variable. Known variable, in most of the cases, it is demographic variable. Then treatments are allocated randomly within each block. For example, this is group 1, this is group 2, this is group 3, and this is group 4. So group 1, 2, 3, 4, it may be on the basis of age, on the basis of income, on the basis of education, anything. And within the group, you are dividing group into different groups. So first group is second treatment, second group seventh treatment, third treatment, fifth treatment. तो आपने same group में different treatment किए. So this is called randomized block design. You can see there are two level here, the level of the treatment and the level of the groups. यहाँ पर हमारे पास सिर्फ दो level है. We are dividing the units into different groups, and each group is divided further for further treatment. So this is called randomized block design, and very popular design in the pharmaceutical or experimental design. अब इसको in experimental design, this is very popular. Now, after that, there is one more complicated design. इससे ऊपर level का जो design है, that is the Latin square design. Now, in Latin square design, we have three levels. There are three levels. Now, what are three levels? जैसे in previously, one level I mentioned is the demographics. The second level we fix is the uh, let's say education. And third is the performance, which is my outcome variable performance. So there are three levels. I want to check the impact of education style on the performance. So in education style, I keep two style, case study and Blackboard. So there are two levels in education style. In demographic, I divide the group into two groups, let's say uh, male and females. And performance, we are assuming that there are two levels of performance, normal performance and excellent performance. Okay. So now you have to take different possibilities or different possibilities. Like I'm giving you one more example. Yeah, थोड़ा सा एक गड़बड़ है because performance is the outcome variable. So you cannot divide the groups on the basis of the outcome. तो performance को हम हटा देते हैं यहाँ से. Let's say age group, age group, young and old. Now the question is that how many permutation and combination you can make. So there could be many combination like male, case study, and young. Here, this is one combination. Then male, blackboard, and young, male, this and this. So there are many permutation and combination from this. So we make all the permutation and combination in such a way we can compare the different possibilities. So this is called latent square design. So one more example I'm giving you. In one example, we are having three factors. These three factors are cars. Suppose you are having different brands of car. Let's say brand 1, brand 2, brand 3, brand 4. आपके पास चार ब्रांड की कार है, चार तरह की कार है आप मान लीजिए. And the drivers of all the, you have four drivers A, B, C, D. And there are four petrol brands A, B, C, D, capital A, B, C, D. Now you want to check how the impact of the petrol brand and driver uh, have a significant impact on the mileage. So mileage rate is the dependent variable and it depends upon type of car, type of driver and type of petrol brand. तीन चीजों पे आपका डिपेंडेंट वेरिएबल इन्फ्लुएंस डिपेंड करता है. So sometimes the outcome variable depends upon three factor. If the outcome depends upon only two factor, then you can go to randomized block design. But when there are three important factors have an impact on the dependent variable, then you have to find out latent square design. So now, if we go for permutation and combination, the permutation and combination are 4 multiplied by 4 multiplied by 4 equal to 64. So there are 64 permutation and combination like पहली कार, पहला ड्राइवर, पहला पेट्रोल ब्रांड, पहली कार, पहला ड्राइवर, दूसरा पेट्रोल ब्रांड. So these are the combinations. So we have 64 combinations. So it is very difficult to make 64 groups. So we have to design in such a way that maximum possibilities are covered. कैसे? So in latent square design, the compulsory input is the three factor which can impact the output, and we have to make design like this. Okay, so I'm showing you the latent square design. In Latin square design, there are three factors. The first factor is car, like first car, second car, third car. These are the type of car. These are the type of drivers, ABCD, and they are using the petrol. So ABCD. So these are the possibilities. So you can see that there are different type of combinations. So for example, this combination is that driver A using petrol A in car 1. Similarly, this is driver A using the petrol B in car 2. So all the 16 possibilities we can measure like this. And then we will measure the mileage of each combination. So for different combination, you have to find out the mileage per kilometer. So then you can compare and find out which combination is the best combination. So it is quite complicated experimental research design, but more complication means more accuracy, and more accuracy means more publication potential. Simple. So Latin square is found to be the one of the complicated but mostly used experimental design in the research. Now the last is factorial research design. So in factorial research design, we have to find out the interaction of any two variable on the dependent variable. So it is just like two-way ANOVA. So there are three examples I gave to explain what is the factorial research design. For example, suppose a study on the effect of different type of learning environment. यहाँ पे हमारे पास दो तरह की environment है, offline, online, PPT, case study. So what is the interaction between them? दोनों में interaction देखें कैसे होगा? Online with PPT, online with case study. Offline with PPT, offline with case study. So there are four type of groups on the basis of the interaction. So when you do the interaction, so there are four groups you will take. This four group is known as 2x2 factorial design. So this is one of the example of 2x2 factorial design. Similarly, you can have 3x3 factorial design, 3x2 factorial design. Like for example, in this case, green. Suppose the yield from different plot in an agriculture experiment depends upon number one, variety of crop, and number two, type of fertilizer. जो बीज है उसकी क्वालिटी और फर्टिलाइजर की क्वालिटी इस पे डिपेंड करता है. So now you have suppose three type of crop and three type of fertilizer. So this is known as 3x3 factorial design, and you can find out the combination of each type and find out the yield of each type. So this is called 3x3 factorial design. So we have the four complicated experimental designs. So number one, randomized block design. Then the third was Latin square design, which where the three factors independent have an impact on outcome. And the third is the interaction of the factors, how the interaction of the factors are having impact on Y. So it is just like two-way ANOVA. So the name is given as factorial research design. So these are the most popular design used by the researchers. And so these are the just factorial design. So how the different combination is influencing the outcome. Now, suppose you conducted some experiment and came out with some result. If anyone else means any other scholar conducted the same experiment and find out the same result. This is known as external validity. This external validity has two components. One is called concurrent external validity and predictive external validity. दोनों क्या होती हैं मैं आपको समझाता हूँ. Concurrent means suppose you are somebody is doing experiment in India and somebody is doing their same experiment in Europe or US, different part of the world. If all the results are giving you same experiment, same result, then this is known as concurrent external validity. जैसे कोविड के टाइम पे क्या हुआ था, कुछ एक्सपेरिमेंट इंडिया में हुए थे, कुछ एक्सपेरिमेंट सेम एक्सपेरिमेंट आर डन बाय यूएस, सेम एक्सपेरिमेंट इन यूरोप, एंड ऑल experiment came to the same result, same conclusion. So when all the results lead to same conclusion, this is called external validity. Now, what is predictive validity? If you conduct the experiment after 2 years, after 3 years, after 5 years, so you are conducting the same experiment at different point of time and finding out the same result. So with time, if experiment is giving the same result, this is called predictive validity. So predictive validity means the application of the experiment in future, and concurrent validity is the application of the experiment over the area. So there are two formats of external validity: concurrent validity and predictive validity. So whenever you talk about the experimental design, so number one, first of all, you have to design the experiment, make a list of the disturbing variables, then how to control them, select a design, obviously quasi-research design. And designing quasi-research design is, they are complicated, they need factors, conduct the experiment, measure output, and compare. So in all the experiments, either we apply ANOVA, MANOVA, t-test, all these statistical tests are applicable. And after applying the test and testing the hypothesis, you came out with the conclusion. So this kind of research mindset will have an impact on your publication. I know some professors in even IIMs, so they are publishing papers only by doing the experiments. So they find out the way of publish paper by doing the experimental design. So that's why this is one of the area where researcher can explore for publication. So with this, I am closing the session. So thank you very much for your participation. Now I'm going to open the forum for discussion. Give me a minute.